Okay, today in this video I'll be doing LeetCode Biweekly Contest 21 and I'll be explaining my solutions afterwards. Problem list is not updating. Okay, finally. Hopefully those few seconds won't affect me. Okay. How long is that? That's not very long. So for this, and find the smallest, okay. Well, it's just greater than, okay. Actually, I only need a frequency array. Should I recode this? Nah, I won't. Smallest character from S is greater, okay. Chart F. Why is this so complicated? Okay, I'm making it a frequency. Okay, and then step 2 is the same, but we go from the back. Now this should be good. No return statement. Oh, the constraints are actually high for this. Okay then. Wait, I am returning something. What's wrong? Okay, seems good. Do I need to use bitmasks for this? Okay, so I'll create a map for vowels first. And then the map for the first occurrence, map of 0 will be equal to 0, and answer. Then, okay, and then the current bitmask, it starts at 0. And if it's a vowel, if we got find is not equal to at the end, then that means we have to XOR. Plus 1 minus, okay, 13, 5, 6. Shit, I didn't mean to press submit. This is so stupid. 14, 5, 6. This should work now. 13, 5, 6, okay. Can't believe I accidentally pressed submit. Okay, this simple recursion. So root 0 and then direction and then accepted, okay. Otherwise return. Okay, so this is right, so return. Three, 4, 0. Three, 5. Oh, wait, you have to do this for. Okay, I see. So that's a native one, and do this for right as well. Okay. This should be pretty simple. Wait, I can't do n squared. And how do I store the... I just return a pair in the DFS, I guess. Second will be the answer, okay. The value of the root and D40, okay, submit this. I need to add the subtrees. I do this for the right node as well. Okay, now this should work. Time will be exceeded. Wait, there are this many nodes? I didn't see that, okay. Okay, let me change my DFS function. Oh yeah, and this is all messed up for some reason. Oh wait, it has to be... It has to be valid. Oh my gosh, okay. equals 0, okay. That means I also need the minimum and the maximum of each subtree to check if it's valid. So answer size min max valid. Accepted, okay. Okay. It's invalid, and then you merge the minimum and the maximum. Okay, this seems good. Minimum is doesn't include the maximum, and then change the maximum. Oh, so MTBST works as well. Okay. Accepted. Oh my gosh, this is terrible. This is actually so bad. Actually, I don't think it might not be that bad because not a lot of people have, 3 and 4 were like a bit harder than usual, I think. maybe. I did not expect this to be solved in... Did not expect I had to do this in linear time. That's why I messed that up. So for this problem, basically you calculate the frequency array of s. So this is what I do in the beginning. For each character, I just add 1 to the count for that character. And then basically I have a while loop, and then at the start of the while loop I check if there are still characters left by looking at if there are any positive elements in the frequency array. And if there are no positive elements, then that means I can stop. And otherwise, I just perform the first step, and then I perform the second step. As so this is the first step, and this is the second step. And for the first step, what I do is I just go through the frequency array C, and then I basically just go through the characters in increasing order. And if there's a character which if there's a type of character which is still in the string, then I add it to the result, and then I subtract 1 from the count. And then step 2 is similar, but instead of doing it starting from 0 and going to 26, I start from 25 and then I go to 0. And I do the same thing. And yeah, this is it for the first problem. For the second problem, this is a problem where we need to use bit masks. So first, let's number the vowels from 0 to 4. And then the reason that we use bit masks is because we only care about the parity of the counts. So let's say we can store the state of a prefix, like so let's say our prefix has 3 A's, has 2 E's, it has 0, 1 I's, it has 1 O, and it has 0 U's. Then our bit mask is just, we take the parity of each of these elements. And then we store it as an integer in base 2. Then in order to make sure that a substring has an even number of vowels for each vowel, that means that it means that in the bit mask, everything should be 0. So wait, okay, let me think about this. So let's say A is, because of our numbering here, A will be equal to, it's different than the numbering here. So A is this, and then E is this, and then I is this, and then so on. And then what we do is we can calculate this prefix of XOR for each of all of the values of the vowels. So for example, if we have AA, EI, then the numbers look like this, and then if we take the XOR of everything, then you'll get 1, 1, 0 in base 2. And this means that I occurs an odd number of times, E occurs an odd number of times, but since A is 0, it occurs an even number of times. So what we want in the substring is that we want the entire XOR value of this substring to be 0. And note that each substring, so a substring from L to R, is actually just the prefix 1 to R, and so you subtract 1, you subtract the prefix 1 to L minus 1 from it. So since XOR satisfies the property that, how do I say this? Okay, XOR, basically to find the XOR of this value, say C, what we can do is we can take the XOR of this prefix and the XOR of this bigger prefix. And then to find C, we just XOR A with B. Okay. So then we want this C to be 0. And if this C is 0, then that means that A must be equal to B. So we want to find the number of pairs of prefixes which have the same XOR value, which you can do easily with a map. So this is what I do. So at the start, the empty prefix, it has an XOR value of 0, and I'm sorry, we aren't finding the number of pairs. We're finding the longest substring. So in the map, we'll store the first occurrence. In the map F here, we'll store the first occurrence that B occurs. So if we find that A occurs, then we'll go to the map and find the first occurrence where A occurs, and then we find the first occurrence so we can have the longest substring. So for the empty prefix, it has a length of 0, so I set that in the map. Then this is the answer so far, and then this is the current bit mask of the prefix. Okay, so I go through each of the characters from the left, and if I find that some character is a vowel, then I XOR the current bit mask with the value of the vowel. So like the value of the vowel is this. So this basically takes 2 to the power of, and then whatever value is here. And then if this XOR value has not occurred before, then I add it to the map. And then this will be the smallest prefix with this value. But otherwise, what I'll do is I'll find, if this XOR value already exists, then I query my map to find the first prefix which has this XOR value. Then I basically use the formula R plus 1 minus L. I use this formula as R plus 1 minus L in order to find the length of this subarray, which ends at I plus 1 and has the first occurrence at the value in this map. Okay. And then for this problem, we basically have one DFS. Then this DFS returns a triple. The first element in the triple, the last element in the triple is, that's the answer for the entire subtree. And then the first element of the triple is the maximum zigzag path if we go left from this node, and the second element is the maximum zigzag path if we start from the right element of this node. So we start with 0 for all of the values. And then if a left node exists, then basically what we can do is we can can go left, and starting from that left child, we'll go right again. So the maximum length of this zigzag path which goes left is equal to 1 plus the maximum zigzag path which starts at the left child and goes right, which is this value over here. And also just take the maximum of the answer in the subtree of the left child. Then I do the same thing for the right child as well. So basically, if there's a right child, then on the right, the path will be go to right first, and then after it goes to right child, we need the length of the maximum path which goes to the left child. So, and then that length is p of 0. Now I add one for the edge from the node to the right child. And then again, we take the maximum of the answer with the answer in the right subtree, which is p of 2. And then finally, we update the answer to be we update the answer with the maximum path, which starts at the current node. Yeah, this is it. And this problem is actually a bit similar to the last problem. So basically, we in each node we return some information to for the answer. So for this, when we DFS on a node, we want to know the answer for the subtree. We want to know the sum of values of the subtree, and then we want to know the minimum value of the subtree and the maximum value of the subtree in order to check that these two conditions. And then we also want to know if this subtree is valid or not. So the answer will just be like the answer. It will be the first element, and then the answer starts at 0, and then the sum of the subtrees and the minimum and maximum both start at the value of the node. And then by default, a single node is valid, so it's 1. And then we go through both the left and right child. So for the left child, we update our answer with the answer in the left subtree, and then the sum of values we also added from the left subtree to our current subtree. And then if the maximum of the left subtree is greater than or equal to the smaller subtree, and then the minimum of our current subtree, which is just the value of the root, then that means that it means that like this tree is invalid. So we set the valid to 0. Or if the left subtree is not valid, then we also set it to 0. And then finally, we update the minimum of this current subtree to be the minimum of the left subtree. And then for the right child, it's similar. So first we update the answer with the answer in the right subtree, and then we add the sum of values from the right subtree into our current subtree, and if the minimum value in the right subtree is smaller than or equal to the maximum in the value of the root node, then this subtree is not valid. Or if the right subtree is not valid, then this tree is also not valid. And then finally, we update the maximum of this subtree to be the maximum of the right subtree. Then if this subtree is valid, then we'll update the answer with the sum of the values of the current subtree. And then we'll just return all of the information. And yeah, this is basically it. Yeah, 15 was really sad this time. especially since like I didn't even want to submit. I didn't even intend to submit this. I just accidentally pressed the enter key and somehow it submitted my solution. But anyways, if any of the explanations were unclear, then please ask them in the comment section below so that I will be able to improve. So if you enjoyed this video, then also feel free to like and subscribe.